Okay, welcome to another session of bioinformatics. I am Dr. Y.V. Rajesh, Assistant Professor, Department of Biotechnology. In today's session, we'll learn about the structural bioinformatics followed by Perl programming. So, structural bioinformatics is nothing but understanding the structure of proteins using various bioinformatic tools here. So till now the focuses concept all the concepts focused on purely sequences, genome sequences, protein sequences, the letters of A, T, C, G or the letters of 20 amino acids here. So here we talk about three-dimensional proteins. We learn about basics of protein structure and then how to predict structure from a sequence, how to predict secondary structure and tertiary structures, and some of the algorithmic approaches for achieving this task here. So basically we know that proteins has 4 levels of hierarchies: primary structure, secondary structure and tertiary structure, and some proteins may have quaternary structure. The primary structure is nothing but linear arrangement of amino acids connected by a peptide bond. Secondary structure is two-dimensional, like a smaller localized arrangement of amino acids with the help of hydrogen bonding pattern. And tertiary is overall arrangement of protein here, overall configuration of protein with the help of hydrophobic interactions, van der Waals, hydrogen bonding and electrostatic interactions. Quaternary is because purely hydrophobic interactions because of different tertiary structures combined together to form a complex here. So basically if you see any protein is made up of a fundamental element called as amino acid. So there are 20 amino acids are there. So all 20 amino acids irrespective of the side chain, they have a common thing here, a chiral carbon atom attached to carboxyl carbon and amino group and a single H and a side chain. So the side chain varies among different 20 amino acids here. So based on the variability of this variability of the side chains, so different amino acids have different chemical properties. So we have glycine, alanine, phenylalanine, leucine, isoleucine, valine, proline, methionine, glutamic acid, aspartic acid. So basically which varies size, shape, charge, hydrophobicity, polarity. So they differ by different kinds of properties, and these properties are exploited by protein functional sites and protein three-dimensional structure here. So you may be classify them as small and non-polar, small and polar, large and polar, large and polar but basic, large and polar acidic, large and non-polar aliphatic, large and non-polar aromatic, like various classifications of amino acids are there. So we already know about the classification of amino acids in the previous sessions, in previous courses we learned about these things. So same basic concepts will be used here. Keeping this difference in mind, we try to understand the structure and function of the proteins here. So you may need to practice or you may need to recap all the structures of these amino acids to understand the structural bioinformatics in a better approach here. So we know that the primary structure of protein is because of linear arrangement of amino acids which are connected by a peptide bond here. So the peptide bond in proteins involves that two amino acids are covalently joined here. The covalent joining is because of the condensation reaction which involves the removal of elements of water from the two molecules here. So the resulting product is called as dipeptide. So this is amino acid 1 and this is the amino acid 2 here. So OH of one amino acid and H of another amino acid will be removed, the carboxyl carbon and amine N. So both are linked together to form the peptide bond with the release of water here. So, and this is an example of insulin here. So here insulin A chain and B chain, we have glycine, isoleucine, valine, glutamic acids, triple letter code is given, chain 1 and chain 2, and these chains are connected by disulfide bonds. So we know that proteins have cysteine amino acid. Cysteine amino acid can undergo dimerizations by release of H2 and can form cysteine. So dicysteines. So this cysteines disulfide bond is very strong, and it can lead to the formation of 3D configuration of different configurations of the proteins here. So the disulfide bond can be internal disulfide bond, within the same chain, or between different chains. Intra disulfide bond and inter disulfide bonds can be there here. So, and coming to the protein secondary structure, here the linear polypeptide, because of hydrogen bonding, it can form into secondary structure elements. So there are 3 different types of secondary structure elements are there: alpha helix, beta sheets and turns. 3 different turns, sheets and loops are there. So all these has specific functioning. They have specific functioning and specific arrangement of hydrogen bondings and different kinds of orientation at the level of local 3-dimensional level here. So we already discussed about the secondary structures in biochemistry course here. So beta sheet, it can be a parallel beta sheet, that is because of the orientation of 2 amino acid chains in the N and C, N to C direction will be same, then that will become a parallel beta pleated sheet. And another orientation is NC is one direction, N is nitrogen, C is carbon here, and NC is another direction here, and it will be anti-parallel beta sheets here. So next one is alpha helix, that is because of hydrogen bond between every 4 amino acids. Suppose first amino acid forms hydrogen bond with 4th one, second one will form bonding with 5th, and third one will with 6th. Like these kind of orientations, you have a right-handed alpha helix here. So alpha helix, beta sheets, and turns we don't have. We don't have specific structures here. So the structures which the amino acids which neither form alpha helix or neither form beta sheets, they can form into these structures here. So this is about basics of structural bioinformatics. So most of the concepts you already know, you already learned. Just we have just recapped the basic things here. Thank you very much for listening to this session.